Hey everybody, this is Mrs. Cooner, and today we're going to be doing a lesson on base 10. A couple disclaimers about my demo before I start. I do live with 4 other girls, so if you hear a little background noise, that's just my roommates. And also, I am left-handed, so if I'm ever covering something up when I'm writing, I'll try to pull back as much as I can so you can see what I'm writing. For all you lefties out there, I feel the struggle. So today we're going to be talking about base 10. And what does base 10 mean, right? So that's going to be one of our big questions for the day. And then also, what does it mean to do arithmetic in base 10? So what's super cool is all of the arithmetic, addition, subtraction, multiplication, we learn from the start is in base 10, but we never even knew it. So we've been working in base 10 all along, but what does that even mean? What does base 10 mean? So that's what we're going to talk about right now. So we've always grown up knowing that it's the ones place, the tens place, the hundreds place, thousands, 10,000s, 100,000s. Okay, well, what's the meaning behind that, right? Who picked these numbers? Why are these numbers what they are? Why didn't we just pick some random numbers, right? So 1 is actually 10 to the 0 power. 10 is 10 to the first power. 100, 10 to the second. 1,000, 10 to the third. 10,000, 10 to the fourth. 100,000, 10 to the fifth, and we could go on, right? Just 10, 6th, 7th, 8th, all the way up. And what's super cool is if we know our exponent rules, right, for tens, it's just the number of zeros behind it. So, but if we had some other base, right, let's say we had base 2, then this would be 2 to the 0, which is 1. This would be 2 to the 1, which is like the 2's place. 2 to the 2, which is like the 4's place. 2 to the 3, which is like the 8's place. And we could do it with any base. We just picked base 10 because 10 has a lot of nice properties. Even when we're learning multiplication and addition, we've seen that those multiplying by 10, dividing by 10, all of that stuff, it's really just a nice number to work in. So that's what we work in usually, is just base 10. So now what does it mean to do arithmetic in base 10? We'll go ahead and start with doing addition. So the first method I'm going to show you guys is lattice addition. This might be a little new to you. It's something I hadn't seen before. It wasn't the way I learned addition, but it's really an exciting way to do it. So let's start with just an arbitrary number, and let's use our place value colors. So let's start with 8,649. So if we look at our colors for our place values, start with 8,649. Sweet, so when I write this number, I say 8,649. That means I have 9 ones, 4 tens, 6 hundreds, and 8 thousands, right? So what should we add to that? Let's add 5,904. Sweet. So again, this represents 5 thousandths, right, because that's the thousands place, 9 hundreds, 0 tens, and 4 ones. So that's what these numbers represent. Each digit is in a place value representing how many of that value there are in that number. Sweet. So now let's work on addition. So we have 9 plus 4. So 9 plus 4 equals what? It equals 13. So 13 has a 1 in the tens place, and then a 3 in the ones place. So here our bottom is going to be the ones place, so we're going to put a 3 here, and then the top is going to be the tens place. Sweet, so now we'll do it again here. So we have 4, which represents 4 tens, so it's actually representing 40, right? So we have 40 plus, and then 0 tens, so just 0, is equal to still 40. So 4, 0. So we still have a 4, and now, because we're working in the tens place, this box down here is the tens, and then up here would be the hundreds if we had something to carry over. So we still have 4 tens, and then we had 0 hundredths for this one. 0 hundreds. Great, so now we can do 6 plus 9, and remember, because we're in the hundreds place, it's 600 plus 900 is what we're actually doing. So we have 600 plus 900 is what we're actually doing, right? But we can just know place value here. So that is going to be 1500, right? Which is the same as 1,500. So we have 6 plus 9 is 15, right? If we're just looking at that. But what's actually happening is it's 600 plus 900 is 1500. So then we have 15. 15 with 1 representing 1,000, 5 representing the hundreds. So now we'll do our last one, which is up here, and it's 8 plus 5, right? So we could just do the 8 plus 5 equals 13 and write a 1, 3 right there. But we want to actually know what we're doing for this, right? Because we're trying to learn. So 8,000 plus 5,000 gives us what? 8 plus 5 is 13. So that would give us 13,000. Let's find my colors. So 13,000. Sweet. So 8 plus 5, 13. And in the colors to represent 1 10,000, 3 thousands to get 13,000. So sweet, so we have all of our place values, right? When we add up in the ones place, we could get ones or tens. When we add up in the tens place, we can get tens or hundreds, right? Depending on how many groups of 10 we have. When we add up in the hundreds place, we get hundreds or thousands. When we add up in the thousands place, we get thousands or 10,000s. Sweet, so now it's really easy to see kind of what numbers we should add together, right? Because they're the same color. So we're going to add across our diagonals because we're adding things that are worth the same place value, right? So 3 is our only thing that will be in the ones place. We have 1 10 and 4 10s. So that adds up to 5 in the tens place, 5 10s. We have 0 hundreds and 5 hundreds. So that's going to be a 500 there. And then 1,000 plus 3,000 is 4,000. And then we'll just carry the 1 over. Sweet. So then our final answer is going to be 1, 4, 5, 3. If we want to practice saying that, it's going to be 14,553. So we have 1 representing the 10,000s, 4 in the thousands place, 5 in the hundreds, 5 in the tens, and 3 in the ones. And that's going to be our answer. So that's what it looks like to do arithmetic in the form of addition, right? To answer this question up here, to do arithmetic in the form of addition using lattice addition. And now you're saying, well, Miss Cooner, this is kind of a lot more complicated than our normal way of doing addition, right? Well, the reason we do it this way is to actually see what's happening. So we can see what the place values are doing and everything that's happening. So I'll show you that this is pretty much the same thing, and we'll do a normal, or quote-unquote normal, I really like this way better, of the same question. So let's do 8, 6, 4, 9, plus 5, 9, 0, 4. And I just realized I totally put the line in the wrong place. So here, let's add a line right there. We'll just say our answer is going to go in that nice little box down there. Sweet. So when we have 9 plus 4, we get 13, which means we normally do 3 carry the 1, right? So what's actually happening when we carry the 1? Well, we got 13, so that's 3 in the ones, and then we carry 1 over to the tens place. And then 4 plus 1 is 5. So now we have 5 in the tens place. 6 plus 9 is 15, right? We got 15 over here. So 5 down here, carry the 1, right? So what are we doing when we carry the 1? We have 600 plus 900 gives us that 1500, so we're carrying the 1 over to the thousands place. And then we have 8 plus 5 is 13, plus 1 is 14. So then we have 4, carry the 1, and again, it's 8,000 plus 5,000 plus 1,000 gives us 14,000, which is the same as 1 10,000s, 4 in the thousands. Sweet, and then we get the same answer. So it's totally fine to use either method. This one, obviously, this work is just to help you guys understand what's going on. That is all the work you really need to do, as long as you understand what's going on. And then this is also an okay way, as long as you understand what the place values are doing and why we carry the 1, right? Because we have to know why we're doing what we're doing. Sweet, so that is addition in base 10. And then I'm going to come back to you with multiplication in base 10, which is also pretty exciting. Thanks, guys.